to run with the presentation. But anyway, so after John, it's hard to talk about the details of VMD and this advanced visualization. So, and you guys are here for a workshop and you're doing baby steps on VMD. So what I want to show for the advanced visualization is showing where do you need to go on VMD to change the few parameters to produce nice structures. Then after that, which is just a few places that you need to actually go. It's more like in your artistic vein, you have to play around and show what you actually want, show your science using the resources that we provide on VMD to show it. And then I'm going to show two movies. They're almost 3 minutes each. And they show an example of using VMD to convey information for your public or for your publication, right? Okay, so you guys are doing baby steps, doing the tutorials that are depicted with figures on top, like with simple visualizations, which can be advanced. You use the ray tracing resources that John mentioned. They can look really cool. And maybe one day you can get to more advanced visualization, playing more with the materials, the shaders, ambient occlusion, and all these sorts of things. So what I wanted to talk right now is simple examples of how to get from a boring visualization to something nice using these resources. And if you want to try to reproduce this later, there is one example of a structure you can get. I wouldn't recommend to get something that big. Go for ubiquitin or something a little bigger so you can explore more features. Well, actually, there's something bigger is the example you're going to use tomorrow for Cyber Shuttle, which is related to what Rafael just showed in the morning, the first talk. And I did that on purpose, and I hope he's around so he can comment on the design decisions or the visualization decisions that he made for his publication. Okay. So how do you go from boring to nicer? So you have to play around with your representation. So in this case, I wanted to show the whole structure of this organelle here. So for a first visualization, I wanted to use like a new cartoon. So you want to depict something. It's a complex structure with many features. And in this case, I wanted to show it like simple. And also want to put some information into the image. So I decided to use the secondary structure and color by it. Well, if you can see clearly in the image, it's not the default representation on VMD. I'm also changing the material of my secondary structure, of my structure. I take a chalky material. But I also did some adjustments to reflection because the chalky is not very reflective. So I changed a bit the material to tailoring to my eye, so to the structure I liked. What else? I did not use the default rendering. It was not just a snapshot of the image. So I used the advanced ray tracing features that are implemented in VMD to show the image. Also, I tuned a bit the lights. I played around with the depth viewing. So in this image, you see that it's a big structure, but it's kind of blurry in the end. So it's kind of shadowy in the end. And I also will use these anti-aliasing samples and ambient occluding samples. Let me get into a bit more details. There were a bit more modifications that I could do using the representation. So the first one was tuning the way I am showing my cartoons. So there's a nice default representation of cartoons on VMD, but you can go here into the settings. So this is current VMD, not VMD2. So at your command or at your wish, you can adjust how thick the cartoons are. You can change the style of the cartoon or the aspect ratio of the helixes or the sheets. So the other thing that, also you change coloring material that you already know. So let's talk about material, but maybe since you're beginning in this, maybe you haven't touched the material settings. So as you can see, VMD has many options of preset materials that you can use. So the one I chose for this example was the chalky because it doesn't reflect a lot of light and looks nice. And well, as John mentioned, you can change many of the properties with material depending on your taste, right? Or what you want to show. So John showed transparent surfaces. So for instance, if you want to modulate transparency of your scene, you can go here to the opacity and change it in different levels, up to the point that you can see clearly the information that you want to convey to your audience. Right? He also showed something about outlining. So if you are showing like in licorice, and you're printing it like to a small size, you can increase the size of your outline to show it better. Any comment? Okay. Yeah, so if your sticks are too small and then you want to improve the outline to improve visualization, you can tune in the parameters as you wish. So the other thing that you can tune, you want me to put next? All right. I do. How's that one? Awesome. Got it. Okay. Okay. So I told about structure, I told about materials, and now I'm telling you about colors. So John showed you that you can use the colors. So we have a user field that you can modulate to convey information also using colors. So, you can choose from a large variety of characteristics. Like, well, the first one I used was display to show the background is white, but you can change the colors of your atom types, atom names, and also chains, molecules, according to what you want to show. And you can finally control all the colors and all the features that you want. If you want to show, like just like you're doing in your digital notebooks, if you want to show things that are, how would I say, sequential, you can pick a sequential color. So you can go to the details in the color scale and change the details of the methods you're using for coloring. So you have color by numbers, but you can also use scales that are visually, I would say, visually, you can detect the grading finally in this color scheme. So you can change the color scheme that is more appropriate to what you want to show. And well, adjust the details. The other comment here is not only you can do that from the graphical interface, you can also do it in a more reproducible way, accessing those commands from the command line. So if you want to make a script to make it reproducible in the future, you can control all these features on VMD.
It's worth mentioning
So
that
that gets us to the other point, is the ray tracing. So you've seen the image that you see normally, if you change nothing, it's a simple one. And if you render the figure using the snapshot, it will be whatever it is on your screen, the way it is being presented. As you may have noticed, if you go to display in the rendering mode, you can change, or depends on your computer, to GL a cell, the shader. It will give you a better representation, or just use the regular one. And John mentioned that we have a feature that is still experimental, which is the real-time ray tracing. So instead of having a single image, you can use, this example is using the Artichrome material that has to show like this representation. So if you use a snapshot, it's ugly or it's basic. But if you use the real-time ray tracing or just render the image, you're able to see like very advanced material with this reflections and this metal-like representation. And you can get the shadows and the ambient occlusion that John showed in those many examples to better convey your image and make it look super cool. And that's what I wanted to show. I will jump on this, as John mentioned about it. But the other feature, the visualization feature that I wanted to show was the using shadows, shadows and conclusion that was previously mentioned, but also using the focus. So you can control how your image is being depicted by controlling the depth of field, and then you can create this effect of blur or bokeh or portrait mode of your molecule. That you blur the background and you highlight features that you want to highlight, not only with color, but also with this bokeh effect, which is nice. So if you want to learn more on how to use those features, that field is accessible here on the display menu, and you have to play around with the f-stop and the focal distance to be able to work on that. Yes, we'll do that. We'll do a live session in the end, and we'll try to play around. But I want to show some examples and something that John mentioned. Yes.
I think those are not so clear for what it is. The narrow and the large amplitude usually overall they have stop.
Yes, f-stop is the aperture. Yeah, it's the aperture of your lens.
Just the cat or everything there.
Yeah, and then you change the focal distance.
Focal distance will be where that thing is.
Yeah, everything is. And I just wanted to show the last something that was pointed by John, that you can do stereoscopic imaging using VMD and then produce your own like YouTube videos, 3D YouTube videos. So you can visualize with, like, if you put your cell phone on your those cardboard support or using a VR glass. So for the next part, that's why I thought I only had 15 minutes. For the next part, I want to show an example that is related. It's not related, it's from Raphael's work in this publication of science. And I want to highlight the mastery of using VMD and the representation. No, I'm not apple polishing here, but it's, I just found it was a good example that you were showing today. So mastery of using the different representations to convey your message, to show your science. So for instance, I'll just show 2 pictures. And one thing that I like, so Raphael used different colors to represent the different domains and also different parts of the protein. So it has 2 domains in the protein plus, so these 2 guys that are highlighted in different colors, but different shades of blue. Not gray, different shades of blue. That show the 2 domains, but also shows an important part of the protein in green, that is a locking strand for the tissue that was shown, and also the peptide in it. So the other thing I like to highlight in this is that there is a consistency on the use of color and orientations among many pictures in the paper. So if you see the one on the top right, so the colors are consistent, the orientation is consistency, it's consistent. It helps you relate among the figures in the publication and also in the supplementary material. So it makes it easy to bring the information. Okay, that's what I want to show, the different angles. You see the arrows pulling everywhere. So a combination of using the VMD to show using ambient occlusion, shadows to help display the message. So in this other one, it's combining representations to show something else. So in the previous one, we had a surface, and now we have this grid-like surface. And I want to ask Raphael why we use grid in here. But the feature that is being showed is the interaction between the peptide and the protein, and that he mentioned previously. It has like a network of hydrogen bonds that's hold it strongly in place. And so the hydrogen bonds are also showed here with the cartoons and also with the relevant licorice atoms in here. In addition, you could just put this this cartoon is transparent, so you could see the details of the liquids of the atom. Well, the other example I wanted to show, also from this paper, is the use of depth of field. So in this figure, it is another orientation showing the twisting, the twisting of the helix in here, and showing all the hydrogen bonds and highlighting the features in the front of the image and blurring the end. So it helps you like focus on the message that you're trying to convey. And another one that I got from the SI, which I also looked nice, is showing the same thing, but now with different, with a combination of representations, showing importance of the, actually was the size of the phenylalanine in the end of the pocket. So he wants to show, to convey volumetric information to help you understand what is going on. So we're in 15 minutes. The next part that I wanted to comment on producing good images is, I mean, you go through all your work of putting up an image, an orientation that tells your message. Go and save your state. So if you are clever and every time you save your state or save your visualization, you can revisit the visualization and do small changes, then save again and render with a smaller or higher resolution or change the settings. Yeah.
Thanks for commenting on that. It's very important because if you submit the paper and you get reviews asking for a slightly different thing, if you want to put it again in the exact same confirmation, it's very hard to have the same state there. You don't need to change all the figures in the paper.
Yes, go ahead.
I have a question about figures in the paper. Ever come back to say that the figures aren't colorblind friendly? How do I do that?
Yes, there's something that you have to take care of.
Yeah, so you have to be careful with that. And depending on the journal you're submitting, that's kind of, you don't even pass for, like, for instance, this science would not accept if you were green or red. You just don't accept it. So you have to be careful with those colors. We have, at least in our group, we have to be careful with that. Again, I think it's something that we talked about creating color schemes in BMD2 that are like
Colorblind.
Maybe just call it colorblind. Then you're sure that you're never using red and green. That's a very common one.
So it also saves time for you. So imagine now you want to work with a mutant of the same protein. You can just copy and paste most of your state file. And you don't have to go through all the trouble of creating your fancy, complicated visualization. And that is something that we do like all the time. Not only saving a state, so if you did the VMD tutorial, saving the viewpoint is also something very important. Because you can save multiple visualization states and navigate through them to tell a story, not only to you, but also to your collaborators. So you can send the file, send the visualization state, the view change rendered file, and your collaborator can navigate the scenes as you explain what you want to explain, right? So it's also useful for teaching. So if you're smart and get organized in saving the states, saving the visualization states to tell your message, in the end, you can put all together to make a movie. And this is also from the paper, and now, yes, because I like the movie, and I think it's a nice example. So yeah, and I'm advertising. So if you save the visualization, you put that in a context, you can tell your own story in a nice way. So it takes 2 minutes. It combines not only the renderings that were produced by VMD in a high quality. I think you used iMovie. I think so. And CorelDRAW to add some still images, and then you can assemble together. So one of the issues was showing the importance of the bulky residues by the end of the pocket that were related to the strength of the resiliency of the bond. And then it's going to show like the same image that we're showing before, but now in the movie, the importance of the hydrogen bond network and the twisting of the the structure. And all of that was being done with PMD and saving different scenes to tell your story. So if a main image is 1,000 words, a movie is like 1,000,000 one. And there's a third process that is being shown here. Was the importance of having all the hydrogen bonds while you're pulling. So it's a steered molecular dynamics that you're going to do tomorrow on Cyber Shuttle with this very same system, but pre-prepared. It's not the very same. And showing the behavior while you're pulling your peptide apart and the resiliency of the SDRG protein to hold it in place. And you're going to see that it only breaks when all hydrogen bonds break at the same time. And there it goes. And since I still have time, I'll show one last piece of this movie, which was using a different kind of representation. Because you were just seeing the cartoon, but now it's the same movie, but now showing the peptide as van der Waals spheres. So you can see better the representation of the impact of their bulkiness in the process. There you go. So other comments on the advanced visualization and movie making. So it is very important for you to make a storyboard. So what we do in the lab when we have to make a movie in this one simpler example that we did for outreach. So we created a video showing the structure of the DNA and the many steps. So and we are going through the various visualization options that you have on PMD. So we also want to showcase what you can do with the PMD. So we make a storyboard and make it with a possible voiceover, but your narration when you're showing the movie, go through all the steps, design the storyboard, and then in the end, you make the movie. But the other comment is when you want to make a reproducible movie, you can just manipulate things by hand all the time. So it's a good practice for you to collect your initial material and organize your scenes based on the storyboards that you created. So this is an example that I made a scene which has a movie which has 20 scenes, and each scene we separate in a folder. And the detail is that each folder actually has a PMD script that shows the visualization state or the view change render. So you can save either like still frames, or you can show visualization changes like transitions. It's a good practice. And in this example, so scene one, it has only one small transition based on view change render. And scene two, we had to go beyond that and create our own transition by hand. So it wasn't available on view change render. And that is an example of the power of BMD. So instead of doing the analysis, we did the movie. So in this scene two, which is just the DNA rotating on its axis, we made a PMD script to rotate it by a certain amount for many frames, for many times, and save at each rotation step a small frame that we can use later to produce the final movie. And with that, I just wanted to show it. It also takes 2 minutes, and I'll take a few questions while the movie is on before we go for a live demo of the real-time ray tracing. At the moment, any question?
How long would you estimate, like, it took you to create that first movie that you showed us?
The first movie was created by Rafael. Yes, and that was like few hours.
It's a long time because you do it many times. It's very hard, especially when you're working on paper, it's very hard to come up with a final idea. But after you have a good idea, you can hold everything, even the horrible part, bring you back, doing it again. It's probably like a day spent doing it. The final version after the paper is ready. There's one thing that you did not mention that I think would be nice. If you go back, that's when you have all the renderings that you provided. The one that you start saying it was nice because of all the people renderings.
This one.
Yeah, that's one. If you look there, you have the different names for the different parts, right? So you have the S3G N3, S3G N2. You guys are used to some big selections like throating rather D1 to 7. I don't do that. I have an STRG N3, I have an STRG N2. You can do that. If you can change your DND, you can have selections that you always do and save them. Right? Like it's not complicated. You make that selection, you create a name for it, and then DND does that for you. I don't think there's a way of doing that with GUI, but it's very easy to do it. So like when I'm working on that,
It's in the GUI.
and then it goes up.
It is in the GUI.
But you can create this, that helps a lot. Because I don't need you always probing and recipe 1, 2, 337. You know, like you don't need to do those things. You can make those selections for you. That's very useful in your database, not just for rendering. Thank you.
So keep sharing, and we try to do a live demo. We can actually show live demo of saving the selection.
Oh, John has a question, but you cannot you
What shall we do?
John, 1 minute. We are bringing your sound back. John.
Can you hear me? Can you hear me?
Yep.
Yes, we
perfect.
can.
Yeah, I was just gonna say that you can create atom selection macros in the user interface. It's in the graphical representations menu. There's a tab there, and you can create atom selection macros for whatever you like, just like Raphael said.
Thank you, John.
There was something I was going to comment on earlier in Diego's presentation, but I can't remember what it was now. But you know, any questions anybody has that Diego or others don't know the answer to already, I'm happy to answer offline or however.
Yeah, like we can hear you now all the time again. So like, feel free
Yeah.
to talk.
Well,
Okay, so
I have another meeting in like 2 minutes, so I'll have to leave. But but Diego can put people into contact with me. Any questions anybody has.
so we wanted to show the real-time ray tracing, right? So now you're just seeing like the regular structure that I tried to color with the simple options. Oh, that's not the right version. I have to kill this VMD. Just a sec.
I've got to run. I just make sure you show them some cool stuff with using depth of field and moving it around. I think that's always fun to show.
Thanks, John.
All right.
Thank you,
Cheers, guys.
Okay, I'll show perspective, which is nice. I'll change the background to white because it was easier to see. Is it better to show black for the perspective? I don't
I
think
think
so.
this screen is better black.
The screen is better black. Okay, keep it black. And we wanted to show us new cartoon. One of the chains. So chain A. Wait. That's colored by something. By secondary structure. So it is in perspective. And we want to show the real-time ray tracing. So if you have, it's available on Linux and Windows. So if you put on that, it is doing the ray tracing in real time. So it gets a bit slower. And it will be just a bit more slower when I activate. So the shadows, you see it on the tab shadows on big software. And the ambient occlusion. So it looks nice, just like. So if you take the advantage of the real-time ray tracer is that now you don't have to go there to the file render. It is rendering in real time. So it will accelerate if you want to do an animation and just see it like super nice with all the shadows and stuff. It is really useful when you represent as a surface or quick search, which is faster. And put on search. Yeah, but as I mentioned earlier, so this specular reflections can be hard to see. So I like to use the choppy representation. It helps you see the shadows and that. So if you work with drug discovery, you want to see the pockets and how the ligand interacts with protein. It helps you to keep some essential of that. So for the depth of field, let's put it like this. And so depth of field changes are available on in here. You see that it's a kind of blurry, but the number of samples is not so high. So to solve that, we make it more blurry. Increase this will be more blurry. And instead of using the real-time ray tracer, we are going to use the real-time renderer. So it will give us a better image while we're rendering. So you go to File, Render, and here you have many options. So the optics that was mentioned, there is one optics that is interactive. So, render. And now you can control using your keyboard the properties of the rendering. And since it's rendering real time, that is adding samples to your render. So it's getting better. The longer you leave it there, the better it is. And I mean, it resets if I'm just pressing the button up to make it more blurry in the back. And once you're satisfied, you just go here and close. Yes, I closed the wrong thing. Okay, you're done. It's rendered. It's saved to your disk. Super cool features. Can't move it. Is there anything else you would like to show? Oh, the focus blur. Yeah, this is the focus blur that we are showing right now. Okay, so I'll open the menus.
Secondary structure will be easier to do.
All right. So we changed the secondary structure. Cartoon. And I will change the real time. So I'll just turn off depth of field. See, it's not blurry. And alpha. And we can change. So as I was showing the picture, the focal point or the aperture or the focal distance. So if I change the focal distance, so I'm changing the focus. Now I can focus. So I can change the focus of what I want to show in the image. So let's blur the end. And
Like we were talking before, like your current DMD does not really have color schemes. You only have the standard colors. You can change all of them if you want to leave your color schemes. But the new DMD, we want to have color schemes as well. If you open PickMD, we can show.
yeah, we can do that.
So PickMD always had color schemes. We want to integrate something like that for the entire VMD now. Just open some model there.
I just want to say,
One R07, that's the one you should. I have a question regarding
yeah, I say,
Those all these features can be applied when we save image in PNG format without background. For example, if we ignore the background, if we want to render the image in PNG format, it maintains the transparency in the background, or
yes, not by default. So it will be blurred, but there's a flag that you need to activate to make the PNG transparent background. Yeah.
The easiest way is to Google find the flag. It's like VMD, alpha, or something like that. Marcelo and I were just talking about it here a minute ago.
Yeah, so the thing that I wanted to mention is that in QuickMD and VMD2 will have directly available for you the color schemes, the color palettes. And one of them will be, one of them will be the color run one. So you will change the color scheme of the whole colors. It will also be easy to change the resolution of the display. A small one. Or
Can you just use the rendering now with different colors?
Sure.
It's already rendering. Just
yeah, it's already rendered.
It's not just. Question should be able.
Yes.
Can you show us how we can actually save the atom selection?
Sure. So the atom select, you can save creating a new macro. So
Joe just mentioned that there was a different way. I don't know.
now he was mentioning you can save your atom selections as a macro. I don't remember by head by heart how to do it, but I think it's atom select. Yeah.
Set cell.
No.
atom select, is that
Yes, you can, but then you want to create a macro. Yeah. I'm pretty sure it's atom select macro.
You make sure that you put it in tab in the graphical presentation. You can go there.
In here?
Yeah.
Oh yes. Oh, selections.
Yeah.
You create a new
Yeah,
macro.
one, yeah. Right.
There's
I've
a-
never done that. This.
No, there's no way to save it right now.
Yeah.
Oh, no, this and or maybe you have to go all the way to. I never done that. And
See, there are so many things in PMD that.
yeah, so yeah, this is the way for you to create a selection. So you're using the keywords to compose the selection in here. But in here, it is inactive for you to create a new macro. So then the macro you have to create on the command line by now. Yeah, I don't remember by heart, but yes, there is an option that you will save and actually select macro, give the name of the macro. Output test. Protein and yeah, so that's it. Add select macro protein and chain A, and you should.
Maybe it doesn't show there, but you can.
No, something changed. Oh, here, there it is. Test. Protein and chain A. So for the case of SDRG and the domains that you mentioned, so you come here to the right now, it goes only on the command line, and you create an add-on select macro for your selection.
Yeah, now you can just type instead of chain B. You
Yeah.
just type.
Actually test.
Twice type test.
Yeah, if you type test and it works. I can modify the add-on selection. So test will be backbone. And it created a new class. Great. Enter.
Just apply again because it's showing you.
Yeah. Now jumps on the backbone atoms. I can do name C alpha. And then apply on C alpha. So you can change the macros at will.
So now you never have to type again the name of your protein slash, something, you just type a name that you could create, it stays there. So. But now that macro that you just added, it's added on the session. If you add that to your VMDRC file, which is what is in your home directory for VMD, that stays for your VMD forever. Every time you load VMD is there. Then you have that forever.
Yeah, so on that comment, so if you want the modification to persist, you have to modify your VMDRC as indicated in the manual. Do you want me to show it? Yeah, it could be anything. So if you wanna, yeah, if you wanna save your work on, okay, let's start from scratch. So a good thing to, if you wanna save your selection by hand, if you want, you can log your commands to a file or to the console. I'll just log to the console so you see the commands here being executed. So I want to create a new representation with, well, chain A only. And take a look at the terminal. When I click create representation, here's the command line that you can save from your VMDRC to have that representation. And basically, this is what is being saved on your session file. So every time you open a session, it will save the PDB that is loaded as a command, and it will save all the representation creations that you did. Not only that, so if you go and change, okay, my new cartoon, I want it to be thicker for whatever reason, not thick. You can adjust the thickness at your will. And if you save the representation or visualization state, the command to modify the way the cartoon is displayed is saved there forever.
Do you have some more quick questions, Diego? I would like for us to